Hello guys, welcome back. So this is continuation of our last class. So in last class, we have discussed up to communication types. In IPv4, we have three types of communications. Unicast communication, broadcast communication, multicast communication. We have these three communications in our last class. Unicast communication is one-to-one communication. Broadcast communication means one to all communication, one sender, all receivers. Multicast communication, one to group communication or group to group communication. Example, video conference and voice conference. In video and voice communication, we will use these IPs. In normal communication, in normal data communication, we will use unicast IPs. What are the unicast IPs? Unicast IPs are Class A, Class B, Class C. Class A, Class B, Class C IPs are unicast IPs. Remember this point. If you use Class A, Class B, Class C, we can send data only one person at a time. But if you use the multicast IPs, we can send data multiple users at a time, multiple destinations. For example, I have 5 computers, computer 1, computer 2, computer 3, computer 4, computer 5. If you want to send data from computer 1 to remaining users, you need to send 5 times in unicast communication. Unicast means one-to-one, right? If you want to send data to all users, you need to send like this, here, like here, 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 like this. But in multicast communication, not like that. This all users can receive at a time. We can talk at the same time. Whatever you are sending, these 4 systems can receive at the same time. That is multicasting. Example, video conference, voice conference, like a group call. Okay, right. So now we will discuss. So in last class we have discussed, right, Class A, Class B, Class C. Class A range is Class A range is 0 to 127. Class B range is 128 to 191. Class C is 192 to 223. Here we will discuss only Class A, Class B, Class C. We don't discuss about Class D and Class C. So these are the 3 classes. Class A, Class B, Class C. We already discussed. These are the ranges. These are fixed. We cannot increase, we cannot decrease these ranges. So now here IPv4 is a 32-bit address. Any IPv4 address. Either it is Class A IP, either it is Class B IP, either it is Class C IP. Any IPv4 address is a 32-bit address. For example, Class A range is what? 0 to 127. 0 to 127 means, for example, I have one IP address 10.20.15.19. This is which class? This is a Class A address because first number is what? 10, right? So the 10 comes in between 0 and 127. So this IP address can be considered as a Class A. So Class A IP address is a 32-bit address. If we convert this IP address into binary, we will get 32 bits. For example, we have a Class B. What is the Class B range? 128 to 191. If we take any number between 128 and 191, that is Class B. For example, 172.16.0.15. This is Class B IP address because the first number 172, based on the first number, remember this point, based on the first number we will decide whether it is Class A or Class B or Class C. For example, if you have a one IP address, for example, I have a 200.1.15.20. this is the which class? This is Class C IP because 200 comes in between 192.123. Whenever we are identifying a class of IP address, just first to check the first number only. Don't check second number, third number, fourth number. The first check only first number only. When we are uh, going to identify class of IP address, just to verify, identify based on the first number. So here, any IP address, either it is class A or class B or class C, whatever it may be, any class IP address is a 32-bit address. If we convert this IP address into binary, here see here 10.20.15.19. If we convert this IP address into binary, we will get 32 bits only. 10. So how to, for example, I will convert here 10, 20, 15, 19, right? See here. 1 second. So 10, 10 means what? 1 second. 10, 20, 15, 19, right? So 10, 20, 15, 19. So if we convert this number into binary, how to convert? The first to write values 1, 2, 4, 8, 16, 32, 64, 128. What is the first number? 10. 10 means what here? So here which numbers we need to add? 8 plus 2. So 8 plus 2 equal 10. So 8 becomes 1, 2 becomes 0. Remaining all are zeros. Next to 20. 20 means what? 16 plus 4. 16 and 4. 20. Remaining are what? Zeros. Next 15. What is the 15? 15 means 8 plus 4, 12, 12 plus 2, 14, 40 plus 1. So these becomes ones, remaining all are zeros. And 19, what is 19? 19 means 16, 16 plus 2, 18, 18 plus 1, 19. Remaining all are zeros. See here, 10 equal to 8 bits, 20 equal to 8 bits, 15 equal to 8 bits, 19 equal to 8 bits. So every IP address, every number equal to 8 bits. Total how many bits here? 32-bit address. So if we convert any class IP address, either class A IP address or class B IP address or class C IP address, any class IP address, if we convert into decimal into binary, we will get 32 bits. Remember this point. 32 bits. So next what happened? These 32 bits means how many bits? How many bytes? 32 bits means 4 bytes, right? So IPv4 is a 4-byte number. You can say like that also, right? So these 32 bits are divided into again two portions. Two portions. What are the two portions? Network portion and host portion. Remember, this is very, very important. Network portion and host portion. Every IP address is divided into two parts, network portion and host portion. In every IP address, either it is class A or class B or class C. Every IP address is divided into two portions, network portion and host portion. For example, if you take class A, so in class A total how many portions? Total we have 4 portions, right? We have 4 portions, either it is class A or class B or class C, whatever it may be, we have 4 portions. First portion is the network portion, second portion is the host portion, third portion is the host portion, fourth portion is the host portion. Network, host, host, host. Host means what? Host is nothing but device, any device. It is technical term. If we connect any device into network, that is called host. Host, H-O-S-T, host. So in class A, we have one network portion and we have three host portions. In class B, the first portion network, second portion network, third portion host, fourth portion host. In class C, we have network, 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 and host. So in class B, there are two network portions and there are two host portions. In class C, there are three network portions and one host portion. In every class, we have four portions, but these four portions are divided into two parts, network part and host part. So in class A, we have only one network portion, one network part. Means how many, each portion equal to how many bits? Total IPv4 is a 32-bit address, right? 32-bit means we have four portions. Each portion equal to 8 bits. So in class A, we have 8 network bits and 24 host bits. If you convert into binary. In class B, we have 16 network bits and 16 host bits. In class C, we have 24 network bits and 8 host bits. These bits are not fixed. We can customize these bits. By default, class A is given 8 network bits and 24 host bits. These are not fixed. Remember this point. By default, class B is given 16 network bits and 16 host bits. By default, class C given 24 network bits and 8 host bits. Okay. Now first we understand what is the use of this network portion and what is the use of host portion. So how to understand this? The first we understand what is network and what is the host portion. Very, very important. I will give you one example. For example, I have two computers, computer 1 and computer 2. Okay, PC1 and PC2. PC1 IP address is 10.0.0.1. PC2 IP address is 20.15.16.19. These two computers are connected each other. There is no any network issue here. Everything is good here. But IPs are, the PC1 IP is 10.0.0.1. PC2 IP is 20.15.16.19. Now, if we send data from PC1 to PC2 or PC2 to PC1, can we send or not? Tell me. Can we transfer data or not from PC1 to PC2 or vice versa? Tell me here. So here, see, listen, understand first here, okay? So between these two computers, we cannot communicate. We cannot transfer data from PC1 to PC2 or PC2 to PC1. Why? Because PC1 IP address is 10.0.0.1, PC2 IP address is 20.15.16.19, and PC1 IP address is a class A IP address. PC2 IP address is also class A IP address because class A range is 0 to 127. So 10 and 20 both are part of the same class, which means these two systems are same class, but these two cannot communicate each other. Why? Because in class A, we have one network portion and we have three host portions. So first portion is the network portion. Means here in 10.0.0.1, 10 is the network portion and 0 host to host to host to. Same here also 20 is the network portion and 15 host portion, 16 host portion, 19 also host portion. So now here if you observe here both are different networks, right? See, both are different network portions. 10, this is the 10, this is the 20, which means these two computers are not same network. These two computers are different networks. This is the 10 series, this is the 20 series. We cannot communicate from PC1 to PC2 or PC1 2 to PC1. If you want to communicate from PC1 to PC2, we need to change IP address either PC1 side or PC2 side. For example, if you want to change the IP PC2 side, here use 10. Now this is the 10, this is also 10. Now these two can communicate each other because these two are same network now. This is actual network. Network means what? Now tell me, network is what? Network is nothing but group of systems. Group can have 2, 3, 4, 5, whatever may be number. Network is nothing but what? Group of systems. Those are using same network portion. So here we have 10.0.0.1, 10.15.16.9 like that. These two now same network. These two can communicate each other. This is a one network. Same way, I will give you one more example. You can easily understand. So I will give real example. In organizations, we generally have multiple departments, right? For example, HR department, IT department, and marketing department. In HR department, there are 5 computers. Computer 1, computer 2, computer 3, computer 4. Same IT department also we have some computers. Computer 1, computer 2, computer 3, computer 4. Same marketing department, we have some computers. Computer 1, computer 2, computer 3, computer 4. So these 4 computers here connected to one network switch here like this. Here also same, one switch, network switch. Here also same. Now we require IP address, right? So here for HR department, for these 4 computers, I will use like this 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4 like this. For IT department, I will use different network. Same class I will use, but different network. Like 11.0.0.1, 11.0.0.2, 11.0.0.3, 11.0.0.4. For marketing department, I will use different network. I will use from class B, 172.16.0.1, 172.16.0.2, 172.16.0.3, and here 172.16.0.4. Now see here, now understand this. HR department, different network. IT department, different network. Marketing department, different network. So in HR department, we have 4 computers. So these 4 computers can talk each other. And IT department, these 4 computers can talk to each other. And marketing department, these 4 computers can talk to each other. But HR department to IT department, we can't communicate. HR IPs are 10 series, 10, but here 11 series. This network is different, this network is different. These 4 are same network. That's why these 4 can communicate each other. This is one network. This is a one network. This is one network. This is one network. Understand now? What is a network? Network is nothing but group of systems and which are sharing same network portion. Very, very important. Please understand this very carefully. If you understand this, we will become master in IP addressing. This is actual network. But now my question is here, but how these HR people can communicate with the IT people? For example, one HR wants to send mail to IT engineer. How this HR can send mail to this IT engineer if both are in different networks? So here we will communicate from this series to 10 series to 11 series by using router. By using a router. In between these two networks, we will use one router. Through router, the communication happens. Remember this point. That is purpose of router. Without router, we cannot communicate from HR to IT or HR to marketing. But within network means see here PC1, PC2, PC3, P4, PC4. In HR department, we have 4 computers. These 4 computers are what? Network. Within the same network. 10.001, 10.002, 10.003, 10.004. These 4 computers are using the same network portion, network 10, network 10, network 10 here, network 10. These 4 computers can communicate each other without using any router. Just we require only one network switch. But if you want to communicate from HR to IT or HR to marketing department, we require a router. The router provides the communication between 2 different networks or more than 2 networks. That is our upcoming class, okay? Not here, right? So just here understand what is network. Later we will discuss what is the network switch and what is the network router in more detail. Here our concept is we need to understand IP address. What is network portion? What is the host portion? That's it. Okay. So now, right? So here this is the network portion and this is the host portion. The next thing is here. My question is here. Just now I have given one example, right? For example, PC1 and PC2. PC1 and PC2 both are directly connected. PC1 IP address is 10.0.0.1. PC2 IP address is 20.15.16.19. Right? As we discussed just now, these 2 PCs cannot communicate each other. Right? That is correct, right? So these 2 pieces cannot communicate each other because these 2 computers are different networks. Here my question is here, in case if you try to send data from PC1 to PC2, for example, I'm sending some message like a hi message to this person. Actually, what this PC does before sending this message to this PC 20.15.16.19, what this PC actually does. So here actually what happened before sending this hi message to PC2, the first PC1 checks whether destination IP is same network or not. This is the source PC. Source means sender. Remember this point. Source means sender. This is the destination. Destination means receiver. Destination means what? Receiver. This is the source IP. Sender, okay? This is the sending PC. This is the receiving PC. I am trying to send this message to this PC2. But PC1 will not send the data to PC2 because the first PC1 checks whether receiver IP is same network or not. Whether receiver IP is same network or not. How it will check? So here what happened? Sender IP address is 10.0.0.1. This is the class A, right? So class A means how many network bits and how many host bits? 8 bits, right? So here internally system maintain this IP in binary format. 10.0.0.1. What is the 10.001 in the binary? 10 means like this, right? 0 0 0 0 1 0 1 0. Remember, okay? This is the 128. This is the 64. This is the 32. This is the 16. 8 4 2 1. Like see, 8 plus 2 equal 10, right? And the next one 0. 0 means all zeros. And 0 means all zeros. 1 means this is the 1, right? This is 10.001. So PC1 IP address in binary. PC1 will also convert receiver IP address. What is the receiver IP address? 20.15.16.19. So 20, what is the 20 value? 20 means 16 plus 4, right? 16 plus 4 means 0 0 0 1 0 1 0 0. This is the 20. Now here actually what sending PC will do, before sending this data, before sending this hi message, PC1 will compare network bits In the PC1, how many bits are there? 8 bits, because it is a class A. In class A, by default, we have 8 bits. So PC1 will compare the first 8 bits, whether these 8 bits are same or not. See here, the sender IP 00001010, but receiver IP 0001. See, it is mismatching, not same. If any one bit in the 8 network bits mismatch, this PC1 will consider that PC2 is not same network. That is a different network. This is how PC1 will check whether destination IP is same network or not. This is how receiver IP address is same network or not. Remember this point, very, very important. Before sending data, the first sending PC will compare network bits same or not. If network bits are same, then it will forward. If network bits are mismatching, any one bit is mismatching, then it will not forward. If we have router, then it will forward to router. Through router, it will communication happens. Without router, data will not forward to receiver, destination. Remember this point. Very, very important. The network bits are very, very important here. Host number can be any number. Host bits can be any bit. That is not matter here. If network bits are same, which means both computers are same network. If network bits are different, both computers are different networks. Right? So up to here clear? Okay. My next question. My next question is, how this PC will know how many bits are I have network bits and how many bits are host bits? Very, very important. Okay, in every IP address we have 32 bits. See here, we have configured IP address 10.0.0.1. Okay, so this is the decimal number. Whenever we configure IP address in decimal format, system will convert into binary. So in the binary, in binary, we will get 32 bits, right? In binary, we will get 32 bits. In binary, we will get 32, right? So here 10.0.0.1. This is the decimal number, just to only for human understanding. But internally, system maintains this IP address in binary format. So binary format means like this, right? 00001010. This is the 10. Next second value 0, right? 0 means all zeros. Next 0. 0 means what? All zeros. Next 1. Next 1 means like this. See total here, how many bits are there? Total 8 bits, 8 bits, 8 bits, 8 bits, 32 bit address. Same way, whatever you assign IP address, either it is class A or class B or class C, that is not matter here. So whenever we assign IP address on system will simply convert decimal into binary. Decimal into binary. Decimal into binary, right? So after converting decimal into binary, how system will identify what are the network bits and what are the host bits? Total here 32 bits are there, right? In 32 bits, these are the network bits are like these are how system will identify, because it's very, very important, right? Because why it is important? Whenever PC is sending data to another PC, that PC needs to verify whether destination is same network or not. How it will verify? By comparing networks. First of all, this PC should know how many bits I have network bits. For example, this PC has 8 network bits. It will compare with only 8 network bits with the receiver IP. Right? That's why it is very, very important, right? First of all, my question here, how PC understand, how PC will identify what are the network bits and what are the host bits in my IP address, like that. It is very, very important. In every IP address, we have 32 bits. 32 bits. Either it is class A IP, either it is class A IP, class B IP, or class C IP, whatever it may be. Any class of IP address is a 32-bit address. In 32 bits, we have some network bits, some host bits, right? We already discussed, right? So in class A, 8 network bits, and class B, 16 network bits. In class C, we have 24 network bits. These are the default bits, okay? Everyone knows, okay, everyone knows right here. But my question is here, how system will identify how many bits I have network bits and how many bits I have host bits? So here, to identify the network bits and host bits in IP address, we have some value that is called subnet mask. Subnet mask, very, very important. Understand this. Subnet mask. The subnet mask is used to identify the network bits and host bits in IP address. Without subnet mask, system cannot identify the network bits and host bits in IP address. Without subnet mask, system cannot identify the network bits and host bits. Okay, now we will discuss what is the subnet mask for class A, class B, class C. Okay, so now see here. So in class A, how many network portions? We have one network portion, we have one host portion. In class B, we have two network portions and three host portions. Two host portions. Class C, three network portions and one host portion. These are default, not fixed. Okay, default means we can customize this. Okay, so why we customize this, later we will discuss that in next class, right? So in class A, by default, one portion equal to how many bits? 8 bits. Remember this point, one portion equal to 8 bits. One portion is nothing but 1 byte. So in class A, there are 8 network bits and 24 host bits. In class B, there are 16 network bits and 16 host bits. In class C, there are 24 network bits and 8 host bits. So here now, subnet, what is subnet mask? Class A subnet mask is 255.0.0.0. Class B subnet mask is 255.255.0.0. Class C subnet mask is 255.255.255.0. So class A mask is 255.0.0.0 because we have only one network portion. In class B, we have two network portion. That's why the mask is 255.255. 255 is considered as a 8 network bits. Remember this point. In class C, we have three portions, right? So 3 255s, 255.255.255.0. This is default subnet mask. The subnet mask purpose is to identify the network bits and host bits in IP address. Very, very important. Remember this point. Subnet mask is used to identify the network bits and host bits in IP address. Without subnet mask, system cannot recognize how many bits are network bits and how many bits are host bits. This is main purpose of subnet masks. Subnet mask cannot describe about class. For example, whenever you see, for example, like this 10.0.0.10. What is the mask here? The mask is 255.0.0.0. I will show you how to configure IP address. Now you can understand this. So here, first how to configure IP address, right? So first to go to command prompt, in run, type here ncpa.cpl command, ncpa.cpl, enter. Here see, here we have some networks here, network cards here. This is 1, 2, 3, 4, 5, 6. Total 6 cards are there. Okay? These all are the network interface cards, Ethernet cards. How to assign IP address? Very simple here. Take any one here. For example, Ethernet. Okay, right click on Ethernet and properties. And here select IPv4, your Internet Protocol version 4. And now see here we have two options. Obtain IP address automatically. Second one, use the following IP address. Obtain IP address automatically means if we have DHCP server, select first option. If you don't have DHCP server, select second option for manual IP. See here, use the following IP address. When you click on here, see here below this box, these boxes will activate, will enable. See here, click on here, see, right? Now configure IP 10.0.0.1. This is class A IP address. Next what? Subnet mask. Subnet mask. We don't need to assign subnet mask here. Just click with the mouse here. See, system will automatically assign subnet mask. This is the default subnet mask. It is not customized mask. This is default mask. If you assign class B 172.16.0.1, see the mask is 255.255.0.0. That's it. If you assign class C 192.168.0.1, see the mask is 255.255.255.0. This is default mask. System will automatically assign default mask. You can also use customized mask. For example, see here, I will assign 10.0.0.1, but the default is 255.0.0, but I am going to configure 255.255.255. It is also correct. See, system is not giving any error. See here, okay. See, system accepted that IP. It is not error. This is customized mask. This is customized mask. This is customized mask. So later we discuss about customized mask. Okay. The first remember default mask. Class A default mask is 255.0.0.0. Class B default mask is 255.255.0.0. Class C default mask is 255.255.255.0. Later we discuss what is the use of customized mask. Whenever we see in organizations, whenever we see anywhere, not only organization, anywhere, whenever you see IP address 10.10.15.20, the mask is 255.255.255.0. So how can you describe this? How can you understand this? Whether it is class A IP or whether it is class C IP. If you see mask here, you can think like it is a class C mask. If you see here 10, it is a class A address. But how can you consider it whether it is class A or class C? Okay, here don't confuse here. So it is class A IP address only. Subnet mask purpose is to identify the network bits and host bits. That's it. Subnet mask will not give the information about class. So this is the class A because this is a 10, right? 10. So based on the range, we will identify the class. That's it. Not based on the mask. The mask is to identify the network bits and the host bits. So here 255.255.255.0. This is the customized subnet mask, not a default mask. So here 255 equal to 8 network bits, 255 equal to 8 network bits, 255 equal to 8 network bits. See here, by default class A network host to host to host, right? We can convert this portion into network, this portion to network. Then mask will be changed. Remember this point. Whenever we change host bits into network bits, the mask would be automatically changed. Simple thing. This is our next class, okay? So why we change host bits into network bits, that is our next class. There you can understand clearly, okay? Just first to understand here uh, the main purpose of the subnet mask. The main purpose of subnet mask is to identify the network bits and host bits in IP address. That's it. Okay, this is about subnet mask, right? So now next we will discuss about IPs are two types. IPs are two types. What are the two types? Private IPs and public IPs. Private IPs and public IPs. Remember, very, very important. Private IPs. Private IPs are free of cost. No need to purchase. No need to purchase. Free of cost. And public IPs are not free of cost. We need to purchase. So whenever we take internet connection from internet service provider like Airtel, VI, okay, some from any internet service provider, if we take the internet connection, ISP will provide public IP. Public IP purpose is to access servers in the internet like Google, YouTube, Facebook. If you want to access those servers, we should have public IP. Actually, we are paying money for public IP. Private IPs are free of cost only for within the organization, within the company only. For example, I have a 5 computers, computer 1, computer 2, computer 3, computer 4. Okay, this is my startup company. So I have only 4 employees. Okay, I have only 4 employees. So, okay, these 4 employees should be able to communicate each other. If these 4 should be able to communicate means, so this should be these 4 computers should be able to communicate each other. For example, computer 1, computer 2, computer 3, computer 4. In the computer 1, there is some data. This data should be uploaded into system 2 from computer 1. But how it will do? So here we require IP address, right? Here we require one IP, here also we require one IP. This is my internal. This is the communication between my computers only. I am not communicating to Facebook or Google, right? So here, this is our internal. This is my private. So here we will use the private IPs. Free of cost. Anyone can use private IPs. In case if you want to communicate with the internet, Google, Facebook, YouTube, then we require the public IP. Otherwise, public IP is not required. If we have a 2 computers, computer 1 and computer 2, and to connect these 2 computers like this cable, via cable, then what happen? If you want to transfer data from this P2 to this PC, here we require one IP, here we require one IP, right? So here we can use private IPs. No need to purchase IPs. No need to take permission from anyone. So for internal purpose, okay, in organizations for internal, okay, within the internal, we will use private IPs. Private IPs in class A, class B, class C, we have some private IPs in class A, class B, class C. Very, very important. In class A, we have 10.0.0.02, 10.255.255.255. In class B, 172.16.0.02, 172.31.255.255. In class C, 192.168.0.02, 192.168.255.255. These are the private IPs. Whenever you see these numbers, Immediately we have to identify these are the private IPs. Here you can easily remember class A is 10, only 10 series. You can easily remember whenever you see 10 series, oh, it is a class A IP address and it is a private IP address. You can easily recognize. And if you see class B, so in the class B, very important. See 172.16 to 172.31, between 16 to 31, 16, 17, 18, but first number is 172. For example, if you see 172.16, 17.0.100, this is which IP? Private IP, public IP. This is private IP because this is 17. Any number in the second portion, 16 to 31, that is private IP. For example, if you see 172.15.0.100, this is which address? This is public IP because 172.15. If you see 172.30.15.100, this is what? This is also private IP because 30. Okay, so like this, we need to identify the private IPs and public IPs. Very important. Okay, remember these private IPs are fixed IPs. In organizations, we will use these IPs only, class A, class B, class C only. In the class C, any IP address starting with 192.168, 192.168. If we see 192.168, this is private IP. If you see 192.167, that is a public. If you see 192.169, that is a public IP. If you see 193, that is also public IP. Only these IPs are private IPs. For example, if you see IP like this, 193.15.20.100, this is which IP address? This is the which class? This is the class C, right? Because class C range is 192.223. So this is the first number is what? 193, right? This is the one, this is the class C. But in this class C, this is which IP? Private IP, public IP. This is the public IP because private IP is always starting with 192 and 168 here. Remember this point. These are the private and public IPs. Very important. Private IPs and public IPs. Private IPs are free of cost. Anyone can use, but we cannot access internet. We cannot access internet. Public IPs are not free of cost. See here. Okay. Okay. So here we don't have. So private IPs are free of cost. We cannot access internet. Remember this point. Private IPs, we cannot access internet. Public IPs means we need to purchase from the ISP. We need to purchase from internet service provider, and we can access public servers like Facebook, YouTube, LinkedIn, any server in the internet. This is the main difference between private IPs and public IPs. Private IPs are very limited, right? So we have only 10 series in the class A. Class B also we have limited 172.16.0.02, 172.31.255. In the class C also we have limited, very important. Remember this point. Private IPs are very limited. Okay, so next session is next we will discuss about how many IPs are there in each class. In class A, how many IPs are there? In class B, how many IPs are there? In class C, how many IPs are there? Okay, we will discuss this. Now we will discuss priority bits. Priority bits also very, very important. Please understand here. So what is the use of priority bits? Priority bits. So we already discussed, right? So how to assign IP address on system. I will show you one more time. To configure IP address on system, first go to run. So here type ncpa.cpl and here, okay. Now here see, if you assign IP address here, right click on properties, IPv4. Here I am going to assign IP address 10.0.0.1. And if I press tab key on keyboard or if you click with mouse here, system will automatically assign to 55.0.0.0 because it is a class A IP address. And if you assign class B IP address 172.16.0.1, see here, if you click here in the subnet mask here, see system assigned to 55 to 5500. And if you assign class C 192.168.0.10, the mask is to 55.255.255.0. So here my question is how the system identify this class. See here, when I assign IP address from class C, system assign to 55.255.255.0. When I assign from class B, system assign 1 to 55.255.0.0. When I assign from class A, system assigned to 55.0.0.0. My question is here, how system identify this class? Either it is class A or class B or class C, right? The first system should understand that IP, that class of IP address. Then only it can assign, right? When you assign class A IP address, if system identify that IP address as class A, system will assign to 55.0.0.0. If system identify that IP address as a class B, system will assign to 55.255.0.0. But how system will identify the class of IP address? We generally identify class of IP address based on range, right? Class A range is 0 to 127. Class B range is 127 to 191. And class B range is, class C range is 192 to 223. So we can identify class of IP address by using this range. But how system identify class of IP address? That is very, very important, right? Very simple here. I will take some numbers from class A, class B, class C. So here, please understand this. 10, 20. That means this is the first number, okay? 10 dot something IP, 20 dot something, like that, 50 and 127. These are class A. Same way, I will take some numbers in class B. You can take any number, okay? Like this. Now, if we convert this into binary, if we convert this into binary, here 128, 64, 32, 16, 8, 4, 2, 1. What is the first number? 0. 0 means all zeros. 10 means 1010. 20, 16 plus 4. 50, 32, 16, 48 plus 2. 127. So this is 128, right? So remaining all are 127. Okay, so these all are ones. and 128. 128, this is 128, and remaining all are zeros. And 150, 150 means 128 plus 16, 144 plus 2, 160, and 191, same like this. And these all are ones, okay. Now see here, this is, I converted here class A and class B, very simply here. So in class A, if we convert any IP address, into binary, in the first portion, uh, in the first portion, if first bit is 0, that is class A, right? So see here, in every IP address we have 4 portions, right? For example, 10 dot, 15 dot, 20 dot, 30. So this is the class A, right? So system will convert these all portions into binary. It will convert 10 into binary, it will convert 15 into binary, it will convert 20 into binary, it will convert 30 also. But system will check only first portion. In the first portion we have 8 bits, right? In the 8 bits, first bit is a 0, that is class A. System understand, oh, it is class A IP address, like that. And if first bit is 1 and second bit is 0, that is a class B. That is class B. Same way, class C, like 192, 200, like you can take any number, okay. So if we convert 192, you will get like this, see, 128, 64, 32, 16. 192 means 128 plus 64, 192 and 0 means third bit is 0. 200 also same. Up to 223, any bit, 192 to 223, if we convert any number, we will get in the third bit 0. These bits called priority bits. So based on this priority bit, system can identify the class of IP address. System can identify the class of IP address. Very, very important. So class A priority bit is 0. Class B priority bits are 1, 0. Class C priority bits are 1, 1, 0. Remember this point. 0, 1, 0, 1, 1, 0. Class A, class B, class C. So based on this priority bit, system identify the class. Based on that class, system will assign the default subnet mask. Okay. So in next session, we will discuss about reserved IPs.